So let's do something simple now. So express minus 2.431 in the form A over B. Of course, where A and B are integers and B is non-zero. So to express in the fraction form, I think this is the most complicated part where there's a number that is not sitting under the bar, some numbers under the bar, there is some negative. I think this is where we get difficult. So you let any, I like x, you let x be equal to negative 2.431 bar. And then count the numbers that are not under the bar. Count the numbers that are not under the bar. So here we have one number not under the bar. So we multiply everything by 10. So we have 10x is equal to minus 24.31 bar. From there, you multiply now by how many numbers are under the bar. So we have two numbers under the bar. So we multiply by 100. So that now we have 10 times 100, it's 1,000. Here, minus 24.31 bar. And then we subtract. So we say the lower one minus the upper one. So 1,000 minus 10, we get 990 x. 31 bar minus 31 bar, that's 0. So now we remain with negative 2.431 minus 24. So it should be like, this gives you a plus, so we're subtracting. So we'll say 31 minus 24, that's 7. So we have 247. So here we have I think I haven't done a good job there. Let me subtract properly. So if we get that one becomes 2, 1 there, 11 minus 4, that's 7. Yes, 2 minus 2, that's 0. Okay. And then 4, 2 minus. So we get minus 2.407. Then we divide by 990. We divide by 990. So we have x is equal to minus 2.407 over.
I have a question.
990. Okay.
I can ask.
Yeah.
Since both of them like have the negative sign, and then you're saying we should subtract from the other, we're just going to ignore the negative sign. It won't become like positive. Like, do you get my question?
I get the question.
Yes.
So we
that
have
was my
this
question.
minus. We have minus a, for example, minus b. So we end up having minus a plus b. Meaning we have like b minus a. So it is subtract.
Okay, I understand. You can carry on.
Okay.
So,
Hello.
what of the question that we're doing in the previous video? We didn't finish it.
Fun. I know when you have time, you will finish it, you guys. It's just time, maybe. But you haven't found.
Okay, but I have a question on the same question.
Uh-huh.
There where we had root, it was root x plus root y minus 1, right?
Yes.
Yes. So I saw something like other people would let root y minus 1 be equal to some letter, then they solve. Is that okay? Or maybe
Yeah, it's
it's
okay
not.
also. Because when they are
Thank
done, they will still place them back and do the same work as if they did not let it to be anything.
All right.
Mhm. So consider the rule A star B equal to 2A minus 2B defined on R. Show that star is binary on R. So no one is asking whether it's binary or not. They are saying show that it's binary. So how do we show? That's the statement. You say, okay, these guys, for it to be binary, whatever A and B that you get, your answer must land in the set of real numbers. So your A and B will be real numbers. So whatever you do to them, the answer that they give you should also be a real number. So what you do is you say, okay, A minus 2B is a real number. For all A, B, real number. So n two real numbers I get. If I do A minus 2B, I'll get a real number. This means that even 2A minus 2B is also a real number because 2 to power real number is a real number. So A star B is a real number. Hence, star is binary on R. Okay.
Sir, is it okay to prove with numbers?
To show that it's binary, no, then there's really no room where you can put numbers for that statement. Because the statement says for all A and B, you should have the answer, the real number. So if you show for, maybe you pick 1 and 4, it's only for that. Now we want it to be for all.
Okay.
Part 2 is saying,
Sir,
hello,
so this statement cannot be binary if you are given an option with a square root sign. When they say star A star B is equals to square root sign of something something.
that is the only case when under real numbers, it fails to be binary. Because the square root of a negative number is not a real number. So now, is it commutative? So you want to check if A star B is equal to B star A. That's what we want to check. So let's see. B star A, so A star B already have it. Now B star A is equal to 2B minus 2A. Obviously, this guy is not equal to 2A minus 2B, which is equal to A star B. So star is not fine, is not commutative.
Sir,
Hello.
can you repeat the explanation?
The explanation is that for star to be commutative, we want A star B to be equal to B star A. Since A star B is already there, all we need to compute is B star A. So where there is B, we put A, and where there is A, we put B. And then if there's minus and there's no square, just know that there will be no commutativity. Because 7 minus 2 is 5, but 2 minus 7 is -5. Unless there's a square, if there's no square, there will be no commutativity where there's minus. I think that's the easiest way of keeping things. Okay. So it should be something nice. Kind of easy. Another one. The third part says determine whether star is associative. Is it associative? So to know whether it's associative, you need to check if A star B star C is equal to A star B star C. You need to check if that is the case. So this is where now I can say we can use an example. So we let A to be 1, B to be 0, and C to be -1. So that then we solve. Or what we can do is, there's another question down here. The fourth question is saying, evaluate 0 star, -1 star 2. So what we can do is we can use these same numbers. So we evaluate this. So we say, okay, we need to get -1 star 2. So while there is A, we put -1. While there is B, we put 2. So we have 2 minus 5, which is 1 over 2 power 5, which is 1 over 2. Then we put it now. So now we have 0 star 1 over 32. That is 2, 0 minus 2, 1 over 32. So this is going to be 2, -1 over 16. So we have found the answer for what? For part 5. This is part 5. In part 4. Then you want to use its reverse. So also want to do 0 star 1. I mean star -1 star 2. So we first get 0 star -1. And we say 2, 0 minus 2 times -1, which is 2 power 2, which is 4. And then we now have 4 star 2, which is 2, 4 minus 2 by 2, which is 2, 4 minus 4, which is 2 power 0, which is equal to 1. And as you can see, 1 is not equal to 2 to the power 1 power, I mean 1 over -1 over 16. So that means that star is not associative. So what we do, if there always be this part is always there. If it's not there, you can create your own number like what we wanted to do here, where you say, okay, A to be 1, B 0, C -1. And then put them in this order and also in the other order. Check if you get the same thing. If you get different stuff, then you know that, oh, okay, there's no associativity thing. That's like the target. Okay. Three. Sketch and find the domain and range of f of x is equal to 1 minus x if x is less equal to negative 1. 2 if negative 1 is less than x less than 1. X squared plus 1 if x is greater or equal to 1. So I want to sketch, find the domain and range. So to sketch this, you put negative 1 here and positive 1 here. And then go to the first function and substitute negative 1 there. You get 1 minus negative 1, which is equal to 2. So now you write 2 and put a closed dot because it's included. From there, you can pick any number that is less than negative 1. Let's pick negative 2. Substitute in the same function. We'll get 3. That 3 is bigger than 2. So it's telling us that we'll have a straight line coming in that direction. Okay. Then if you haven't done anything, so the straight line in that direction, yes. Then from there, we are told that from negative 1 all the way up to 1, but 1 not included, the function is 2. So you draw a straight line. Then now get this one, substitute in this function. We get 1 plus 1, which is equal to 2. So we come and close it.
Sorry, sir. Kindly repeat on the second one.
So the second one, we are told is 2. All the way from negative 1 up to 1. So we just draw a line between negative 1 and 1 at 2.
All right, thank you.
Then after you substitute 1, you also pick a number bigger than 1, say 2. So we have 2 squared plus 1, which is equal to 5. So we get 5 if we have 2. Okay, so this is telling us that, okay, here are going to have, and check, this is the square. So a square is not a straight line, it's a curve. So you put something that looks like a curve and not a line. So now after that, you find the domain. The domain is going to be all real numbers. Because the graph goes from negative infinity up to -1, continues from -1 up to 1, continues from 1 up to infinity. But the range, as you can see, the function, the lowest value of the function is 2. All other numbers are bigger than 2. So it's from 2 to infinity.
So I have a question.
Okay.
Did we include the 2?
Why did we include it?
Yes.
Because because you could find 2 by solving. F of 1 gave us 2. F of -1 gave us 2. So it's obtainable. So we don't include if there's no value that includes it. But even if -1 and 1 are said not to include it here, it doesn't matter because in between here, there are so many numbers that are giving us 2, as can be seen from the line. So many of them.
Okay.
Mhm.
I have a question.
Yes.
On the same part where it's 2, -1 is less than x, which is less than +1. On the middle.
Mhm.
So what if it was -1 is less than x, which is less than or equal to? Does that change how you graph it?
Yes. We'll still graph it the same way, except when you just reach 1, we would have included it before we go to the third part. It's about inclusion. Okay, so I think today I don't want to talk about where I've reached now. I'm supposed to start talking about quadratic and the applications. So I don't want to talk about the things that I'm going to terminate at the end of today. But when you talk about quadratic, then we'll talk about the issue of roots, the discriminant, the application, and then we talk about the expected form. So solidify again and take questions that are direct, try to see what we can be asked. So you have a lot of work, you guys. Where we have reached so far, I think this is what I think you can do. Let me just remind you, because you guys deliberate to forget things. So far, I expect you to, 1, be able to answer any question with sets, sets intervals. You can simplify there. I expect you to rationalize. I expect you to prove rationality. and irrationality. I expect you to be able to find, be able to express the decimals into fraction. I expect you guys to be able to answer questions on complex. Complex numbers. I expect you guys to be able to find the domain of a function. Be able to pick the range. Be able to pick the composite. Under composite, you can also find the domains. To get the inverse of functions. To be able to sketch piecewise. You can also state their domains. To be able to answer questions on binary. Be able to show that this function is even, odd, or neither, even or odd. To show that the function is 1-to-1. Okay. I think so far this is what we have done.
Sir, there are videos for all these topics.
Yeah.
Pardon?
Yeah, they're there. They're all coming as examples. So they're all coming as questions in their video.
Me personally, I joined yesterday,
Oh, okay.
so I haven't seen, like, I only saw yesterday's video being sent into the group.
Okay. So you make a follow-up inbox and you have all of it.
All right.
So we'll keep ticking. Tomorrow we'll tick quadratic, the roots. The discriminant, how to tell that this is now have real roots or not. Well, quite a good number of things to check. The idea is that each day that goes, we tick until we have ticked everything. So you should also be ticking on your private books. So you check these, you should write and be sure that you can tick. Don't tick anyhow. Just because you have ticked here, you also tick, no? Make sure that you tick also when you are sure that you can tick. And where you have not ticked, you can capture. You can take a screenshot of this. And after you go through, if you identify that, me, I have not ticked here, you put a cross. Communicate to me that me, I still have a cross here. Even if you have ticked in the group, me, I still have a cross here. I'll be finding ways of coming back and get some examples address them as if I'm talking to the group, but I know that I'm targeting you, then others will benefit as well. Whenever you-
Thank you, Senai Mbonevino.
Sancho.
Mm.